So, good afternoon, students. I have got some of the messages that some of the students have marked their attendance before 2 and that is why they have been marked absent today. So, you don't worry. What you can do is, you can, if you are seeing your self as absent, so you can leave a message in the group on the WhatsApp that I have been marked absent with your roll number. So I will just go through them and correct it later on. Okay. So yesterday we have coming to the class. Yesterday we have completed with the diagrammatic presentation and left with the graphical presentation. So this is the only last part that is left behind in this particular topic, that is the presentation of data. So we will be taking up this today. So this graphical presentation, uh, can see here that so far we have discussed one of the technique of visual presentation, that is diagrammatic. And graphical presentation is a next step ahead in this. And this is the second form of visual presentation. So you will appreciate that how such presentation eliminates the dullness of the data and make it more interesting. What it does? It eliminates the dullness of the data, okay, and it makes the things more interesting, okay, and at the same time it also helps in the comparison of two or more frequency distribution. So here this word has also came, this frequency distribution, okay. So for frequency distribution also we make a graphical presentation, and from that we can have some comparison. Now we will study this important technique of this visual presentation today about the graphical presentation. And you might have seen that in stock index, cricket score, production trends. Okay, whenever there are some trends are given in various magazines and television. Okay, so you might have seen some graphical presentation of it. And everybody, he or she, whether he is an expert or a layman, have a natural fascination for appropriate graphical presentation of data, which remains the essential part of the research method. So we should understand that when we will be doing some research methodology, until unless we represent or present our data in the form of graphs, it does not leave an impact. So the graphic presentation data leaves an impact on the mind of the readers, as a result of which it becomes easier for them to draw the trends from the history. Okay. So they are able to draw some trends that what does this data signifies or trends, what are the underlying trends are there. So the shape of the graph offers an easy and appropriate answer to several questions. Okay. And what are those questions? One is the direction of curve on the graph make it easy to draw comparison. That is, you can make comparisons the graph from the curves. Then the presentation of time series data on graph make it possible to interpolate. Okay, that is, say for example, at a different time point, okay, cross sectional data you have. When we have discussed the data, we have told you about the cross sectional. From the cross sectional data at a point of time, at several points of time, you have some values. But what about between those point of time? So by plotting the graph, you will be able to find out that between those points, these are the points which can be interpolated. As well as you can also extrapolate the values, that is outside the range of the data, and that helps us in forecasting. Okay, that is, you have certain set of data. If you plot a graph, you can forecast that up to this year, if this is the situation, this graph is going in this direction, so most probably by next 10 years this will be the value. Okay, so it is used for the interpolation as well as extrapolation as well as the forecasting of the values. The graph of frequency distribution, if we make the graph of frequency distribution, we can determine certain values of the statistical parameters as well. Those are mode, median, quartiles, percentiles, etc. Okay. So these values can be determined from the graphs itself. Although I will not be touching these things in this lecture because up till now you are not knowing that what is mode, what is median, quartile, percentile. So once you will be knowing these things, so we will it will take simply only a simple technique that because you will be knowing from this particular lecture how to make this graphical presentation. From the same, at that time, we will be telling you that how to find a mode, how to find a median, how to find quartile or percentile from these graphical representations. So, because of these all advantages, it is necessary for a researcher to have an understanding of different type of graphical presentation of data. Okay? So, in practice, there are a variety of graphs which can be used to depict the data. Okay, but here we will be discussing some of the graphs which are frequently being used in business and research. So broadly, the graph of statistical data may be classified into two. Okay? One is on the basis of the time series. Okay? One graphical presentation is on the basis of time series, and other is on the basis of the frequency distribution. Okay, so we will discuss both these one by one. Okay, so before we discuss these things, that how to draw a graphical presentation of time series or on the basis of frequency distribution, let us first find out that what are the different parts of a graph. Okay, so the foremost requirement about from a researcher or as a student is to become aware about the basic principles of using a graph paper for presentation of statistical data. Okay, and how you can do conventionally graph have drawn on graphics. Okay, what you will be requiring for graphical presentation will be the graph paper, and two perpendiculars are drawn which intersect each other at the right angle. That is, you are going to draw two perpendiculars which intersect each other at right angle, and this intersect point is called as origin point. Okay, this is called as origin point, or it is also known as the 0 point. Okay, the horizontal line intersecting lines two perpendicular. The horizontal line is known as x-axis. Okay, that is the horizontal line is known as x-axis. Whereas vertical line, the vertical line, and this x-axis is also known as ordinate. We also call it ordinate. Okay, and on this particularly, when you use your graphical presentation, independent variables are on ordinates or x-axis. Whereas vertical line is known as the y-axis or the abscissa. Okay. And this on this particularly dependent variables are generally mean, that is which varies on the value of the x. Those are shown on the y-axis. The graph paper is thus divided into four parts termed as quadrants. Okay. And these quadrants are meant to depict the positive and the negative values of the x variable and the y. And by observing the following figure 9, okay, you want to understand clearly that what is the purpose of a quadrant of a graph. So you can see from here, if I just I, a little bit, so you will be able to see whole of the graph. So there are four quadrants are there, and now you know that this abscissa is the y-axis and the ordinate is the x-axis. So in the first quadrant, both of these are positive, whereas in second quadrant, these are abscissa are negative, ordinate are positive. Third, both are negative, and in fourth, the abscissa is positive and the ordinate is negative. Okay. So these are the parts of the graph. These are the two perpendicular lines. They intersect each other at this origin. Okay. And according to the, after you just understood that what are the what is axis, yeah, what is an this. Now let us start with the graph of time series. So a time series is a set of values of a variable or variables arranged over a period of time. When you arrange the values of variable or more than one variable over a period of time, this type of graph is known as values are known as time series. For example, data related to production, sales, expenditure, export during the last 10 years or 20 years or 30 years. So these constitutes an example of time series. Thus, a graph of time series is prepared to show the values of one or more than one variable over a period of time. And these type of graphs are also known as time graphs. Okay, these are also known as time graphs or histograms. These are known as histograms because history is represented graphically. That is the over the time what is happening to the variable is being shown in these type of graphs. So they are also known as histograms. So these graphs are helpful in studying the change over a period of time as well as for the forecasting. So histograms can be constructed in two ways. One is on the natural scale, that is on the arithmetic scale, okay, and other is on the ordinate scale, okay. So on the ratio scale. The natural scale graph reflects a change in the absolute value over the period of time, whereas the ratio scale graph reflects the relative changes over the period of time. So, however, we will be in this particular we will be discussing about the histograms on natural scale. Now, construction of a histogram on natural scale. How to construct a histogram on natural scale? So, natural graphs, scale graphs are used to show the absolute values. They are used to show the absolute values or the relative values in terms of percentages, okay, such as index number in a type. So the following principle should be kept in mind. That is, these points should be kept in mind when constructing a histogram, so that the reader will be able to search through the text and in order to understand. So on x-axis, we take the time as the independent variable, and on the y-axis, we take the data as the dependent. Okay. Then we plot the different points corresponding to the given data, and then these points are joined by a straight line. Okay. They are joined by a straight line in the order of time. So, equal magnitude of scale must be maintained on x-axis. That is, whatever the magnitude you are taking for one from there, as well as on the y-axis. And y-axis normally starts with a 0. Y-axis normally starts with a 0. And in case there is a wide difference between the lowest value of the data 0 which we find and the first value, the y-axis can be broken with a false base. False can be broken with a false base. However, we will explain this thing that how to make a false. Now, fourth point is if the variable are different units, then double scale can be taken on the y-axis. When the scales adopted should be clearly indicated and the graph must have a self-explanatory title. Have a self-explanatory title. And generally, one of the drawback of these graphs is that they lend themselves to considerable misuse. Many people misuse them. The same data can give different graphical shapes depending on the relative size of the. So, in order to avoid such misrepresentation, the convention in the research is to construct a graph, and wherever it is possible, vertical axis should be equal to the three-fourth of the horizontal axis. So, there will be a symmetry in the shape of the graph, so that something doesn't become very steep. So after you learn these principles, now we will move on to discuss the type of history. There are different types of histograms and various types which have been developed. So among them, frequently used graphs are one variable graphs. Okay, and they are also and more than one variable graphs are also made. Okay? So now we will be looking for the graph of one dependent variable. So let us see an example of in illustration 6. So here this is the following data relates to the India's export to USA during the period of 1994 to 2000. And these are the years 1994, 95, 96, 97, 98, 99, 2000. And these are the export values which has been exported. So, uh, This is how, as I have discussed with you, the various principle. That is, this is the vertical axis. This is this x-axis, horizontal axis. On the horizontal axis, we take the time, and on the vertical axis, we take the variable. The values generally starts from zero, and then they increase. Okay, and you have to plot the values corresponding that in 1993 what is the value, then in 1994 5310 was the export value in dollar, mark a point, then in 1995 mark a point, and then join these points with a line. So from this line, one can simply see that over a period of time there is an increase. And from this, in between, also we can have some values, and we can also extrapolate them that in next 2001, what will be the possible values here. Okay. So this is the use. But here, what you can see is that there is a large gap from 0 to up to 4500. There is nothing. So this is what I was telling you, that with a false baseline also you can make a graph. So this is what I have discussed here, how to make a false baseline graph. And this is the example of false baseline graph. Nothing has changed. The only thing is that here we have given a cut mark. Okay, that between 4500 and 0 there is a cut mark, so that the below graph can uh, there is less space in the below, and the values remains the same. Okay, so we can more concentrate on the value by using this, and there will be less wastage of the value. So this is how a false baseline can be made on the y-axis if there are no values below this. Okay. So this is them. Then comes your uh, graph of more than one dependent. So here is an example. Again, an data of sale and cost of sale and then profit loss sub company from 1991 to 2000. So these are the sales and this is the cost of sale. That is not sale, how much cost has been incurred. So accordingly, there is a loss of 11 lakh in 1991. Then there is profit, then loss, then profit, then loss, then some values are there. So how to depict this more than one variable on a histogram? So here again, same thing. So self-explanatory title, histogram showing the sales, cost of sales, and the profit loss of the company 1991 to 1000. And there are also the legends. That is, the blue color line shows you the sales, the red color line shows you the cost of sales, and then the profit loss can be seen with the yellow line. You can see here that at 0, because the values have also gone below 0, so we have extended our this vertical scale up to -20, so that this -11, -6, -7 values can also be shown here. And one can very well easily depict from this graph that after 1996 there is a steady increase in the profit of the company. Okay. So this from this histogram we can very well draw out some conclusion that how these values are being changed, and this is the using of this. Now graphs for frequency distribution. So as we have seen for this particular uh, how to show for the histogram, similarly we can have the graphs for the frequency distribution. Already we have studied in the last or previous lectures how to uh, make frequency distribution. Okay, and so here we will be using the uh, how to make the graphs out of those. Now there are certain rules are there. Okay, so in continuous frequency distribution, so the class limits and the mid values they are taken on the x-axis, whereas the frequency is taken on the y-axis. Okay, that is important. Then other thing is the vertical y-axis is not broken, not broken. Frequency graphs. Thus, a false baseline cannot be taken, and a frequency distribution can be portrayed by means of histogram, frequency polygon, Augie curves, and scatter. So the first three we will be studying here. Scatter diagram we will not be studying. Okay? It is not of much use. right now. So histogram, how to make the histogram. So the graph usually drawn to represent the frequency distribution is called histogram. If you are making a graph which shows the frequency distribution, it is called as histogram. And what are histograms? These are the set of rectangles or vertical bars, okay, each proportionate in the width to the magnitude of the class interval. The width of these histograms is the width or the magnitude of the class interval, proportionate in the area and the number of frequencies concerning the class intervals. Okay. So in histogram, the variable class interval are always shown on the x-axis. That is, you will be showing your class intervals on the x-axis, whereas the frequencies will always be shown on the y-axis. Okay, the frequencies will be taken on the y-axis, right? So in constructing a histogram, there should be no gap. Okay, not be any gap between the two successive. Whereas in frequency bars, earlier we have studied, there was a gap between the bars. But in histogram, there is no gap. However, and another thing is that it has to be made from the exclusive form of classes. That is, inclusive form of classes cannot make a histogram. Now, coming to the frequency polygon, how to make a frequency polygon? Polygon means many-angled diagram. Okay. And this is another way of depicting the frequency distribution graph. So it facilitates the comparison of two or more frequency distributions are there. Then you cannot make a histogram of two or more frequency distributions. So in that case, frequency polygons are made. Okay, and frequency polygons can be drawn either from the histogram or the data given directly. So we will be discussing here that how to make the frequency polygon from the histogram, and similarly, we will be able to understand that how to make them direct. Okay, because the direct method is much easier. So first of all, this is the histogram. So this is the title. So you can see that the frequency is on the y-axis, whereas the classes are on the example. The data is here. That is sales in crore. That is 0 to 10 crore, 10 to 20, 20 to 30, 70 to 80. And number of companies making this much of sale has been there. So you can see that 0 to 10 is depicted by first bar, the 10 to 20 is depicted by second bar, 10, 20 to 30 by the third bar. And how to make a frequency polygon? Just take the midpoint of the this rectangle, that is at the 5. So then at 15, then at 25, then at 35 and join them. This line makes the frequency polygon. So if you want to make a direct frequency polygon, you have to take the midpoint and accordingly you make the points and then join them with the line. Makes it kind of midpoints of the class on the. Okay. So this tells you this. Then comes your cumulative frequency curves. Sometimes we are interested, we have studied in our lecture about the less than frequency and more than. Sometimes we are interested in some of the things like how many families in the city are earning less than 5,000 and how many are earning more than 20,000. So these less than frequencies and the more than frequencies can be depicted on this graphs, and these are known as cumulative. And the graph which are made out from the cumulative frequency curves are known as orbits. So these orbits are of two types, less than cumulative frequency orbits and the more than cumulative. So in less than orbits, start from the upper limit. We have already discussed this thing. Let us have an illustration and complete this lecture. This is a data from a sample of 188 small scale industry units in the city. So, operating expenses of these in thousands are 0 to 20,000 in 7 units, 20 to 40,000 units, then 40 to 60,000 units. Okay. Similarly, these are one in total 188 units in which there are different operating expenses. So how to make it less than and the more than cumulative frequency? So for that, first of all, we have to make first of all less than and more than cumulative frequency. So first is operating expense. Then from the operating expense, we will extract out the lower limit and the upper limit. That is the lower limit for this particular class is 20 and the upper limit is 40. Then number of units have already been given to you. Then less than cumulative frequency can be calculated like this 7, then in next it will be 7 plus 18, whatever will come will be added to 22, like this less than cumulative frequency will be calculated, and more than will be that sum of all these, then in the second class sum of all these, and then in 40 to 60 sum of all the kilo frequencies. Okay, so you will be getting these values, all these values, and when these will be, what you can have from this is that, say for example, here this is 20. So the expenses of, so when we will be debiting the less than frequency, so we have to take the this upper limit in less than frequency. So 25 of companies are having expenses less than 40. Okay? 81 companies are having expenses less than 80. Okay? At the same time, these 141 companies have expenses more than 60. That is, in case of the more than cumulative frequency, we have to see the lower. Okay? And when we will be constructing this, so this type of graph will be observed. Okay, that is self-explanatory. This item less than and more than cumulative frequency curve showing the operating expenses rupees in thousand of small scale industry. So you can see from here that this blue color shows the less than frequency. So what we can say is that there are 7 companies whose expenses are below 20. 25 companies whose expenses are is less than 40,000. At the same time, more than zero, okay, more than zero are 180, more than 20 are 181, more than 40 are 160. Like this, we can take the more than frequency from this. And in coming classes, when we will be coming in coming classes, then median will be taught to you. This intersecting point gives us the median. Okay, so to summarize upon, by summary, you can go through the lecture notes. I have put it on the website also. So basically, this presentation of data, when you make, either you make the textual presentation or you make the tabular presentation or diagrammatic representation or this graphical presentation, you ultimately helps the reader to extract out the meaningful information, contextual information from the data in a right way, so that he can interpret that what this data is all about, and at a glance he will be able to understand. Okay, so with this I am closing this presentation of data lecture uh, today, and we will be meeting again in next class, classes. So I will let you know with the next topic again, and thank you very much for your patience hearing. And because there are no questions being put on the this chat box, so I am just closing my lecture here. Thank you very much. Thank you all for patience here.